I know you want to see Leisure Suit Larry and AI, but before we get to that, we have to talk about AI agents. Now, if you do just want to see the demo, skip ahead, the links are down below. But first, let's talk about AI agents. The idea of an agent is that it's essentially a autonomous or semi-autonomous AI-powered assistant that can coordinate with resources, tools, and other such agents to accomplish tasks. The question is, how do we build really good agents? Agents that can accomplish not simple tasks, but really sophisticated tasks. I think to work on this idea, we need some kind of laboratory or playground that is complex enough to provide the challenges we need, something that is multimodal, a challenge that requires different types of skills, a challenge that requires problem solving and reasoning, and can do reasoning on various levels, from immediate tasks to tasks that roll up into other tasks to overarching goals. We also want to work on common problems like hallucination and context rot. We want to learn about approaches for managing context and memory and AI tools and technologies like MCP or Model Context Protocol for interacting with tools. I think we also want a kind of common framework for measuring LLMs against each other that is not based on a benchmark that the AI is fit for. And I think one of the best laboratories that exist for AI agents is a game, because we have control over a game. And when I think of the types of games that are out there, the one that I think matches the need the most is the adventure game. And an adventure game is essentially a game where there is a world and you have quests and you go on these quests to accomplish some overarching mission and their submissions along the way. And the more I think about it, the more I think that the kind of adventure game we want isn't a modern adventure game, at least not to start. It's a retro graphical adventure game like those created by Sierra and LucasArts, like King's Quest, which was the very first one introduced in 1984, Space Quest, and the very famous Leisure Suit Larry, which we'll be playing with a little bit later. And the reason why I think adventure games, and specifically the interactive graphical adventure game, is that it's parser based. So you interact with the world either by moving the character in pseudo 3D space, or you type commands and read dialog boxes. So I think this is a particularly good space for interacting with an LLM and any image processing frameworks that LLM providers also provide. The graphics themselves, they do provide a bit of a challenge because the graphics of that time were so very basic and pixelated, but we'll come back to that. Beyond that, the adventure game offers overarching puzzles, sub-puzzles and sub-quests, characters to interact with, objects to pick up. We're awarded points when we do things that are expected and are good, and there are consequences in the form of points being removed and oftentimes deaths when we mess up. Now, if we want to build this kind of laboratory, we're going to need a high-level architecture, and then as we go, we're going to need to get more and more detailed. So let's start with that high-level architecture. And to get going, I think we can start with just the obvious two components, the AI and the game. And we want the AI to play the game. But in order to do that, we have to understand a couple things. The first thing is that on the game side, it's really a game engine with a game running inside of it. So building on that, we need the AI to be able to speak to the game, and we're going to do that through a game engine AI client. That client is the component that's going to reach out and communicate with the AI and let it know that we want to play. And it's going to broker the top level communication between the AI and the game engine, and thus the game. In order to understand what's going on in the game engine and to really be able to interact with the game engine, we're going to have an AI bridge inside of the engine AI client and inside of the game engine. And that's going to be built with traditional programming. That's basically getting a hold of the game engine and integrating deeply with that. Now, the type of integration that you do there, it depends on what your goals are for the level of information and understanding that the AI has about what's going on in the game. So you can choose to provide only what the player would know versus deep information about variables inside the game engine. And that's more than just an aesthetic choice. That's a question of what are you trying to achieve in terms of the AI being able to mimic a human. Once you have that all set up, then the game engine's AI client is going to need access to a number of things. The first is prompt templates. So basic instructions on what you want the AI to do and how to do it. And then as we get more into really deeply how to do those things and also state of the situation, we get into context and memory. So I would expect the Engine AI client to provide the AI tools with that context and memory. We also may need AI tools. These are capabilities that the AI itself does not have, and they can be specialized to working inside of the game universe. An example of that might be something like a pathfinding tool or something like that, where at a minimum there's really special instructions and you want to give the AI a very directed set of data and instructions and get back specific information to pathfind through the scene or something like that. On the AI side, of course, we're going to have an LLM, and many LLMs provide image analysis, not just image creation, but image analysis. What's in this image? Diff this image from that image and things like that. So those are the two main types of tools that we'd be looking for. And then, of course, inside of them, there's lots of variations between the models that you use and whether or not it's a reasoning model and so on. And underneath that, you have different LLM vendors. So OpenAI, Grok, Gemini, Claude, and many others. The four that I mentioned are the ones that I've been working with. And that takes me back to one more thing that I'd like on the client side, which is metrics. And so how successful is this thing? Are we achieving goals? Are we scoring points? How long does it take for us to make a move? Or on average, how long does a call to the AI take? And then also observability. So I want to be able to see what's going on. What's the decision-making process? How are you choosing to use different tools? And also, pretty much for selfish reasons, I want to be able to watch the AI play the game, sort of like a movie, or as we'll see, in some cases, maybe even have the AI ask me for some help for things that it's not currently doing well and that I want to defer to a later time. And so this gives us a high-level architecture and some goals, because once I have this high-level architecture, then not only can I work towards building a great agent that can successfully play the game and learn a lot about how to build these kinds of tools and thus be able to build all kinds of other AI tools. But I also have a really great test bed to compare one set of AI tools or one vendor's tools to another, right? And it's almost like its own benchmark. Think of it like the Leisure Suit Larry AI benchmark. How far along in Leisure Suit Larry's Land of the Lounge Lizards can you get?
Okay, let's do a demo. So what we're looking at here is the Agile AGI engine written by Lance Ewing. And it is a web-based engine for these 8-bit Sierra games. And I have modified it to run with a client and an AI bridge like we discussed in the architecture. So we're going to start off by loading my game, which is called Let Them Eat Cake, and get acquainted.
It is getting late and you should go to bed, but you cannot sleep. Earlier today, you received a summons to appear at the castle to meet with King Edward for reasons unknown.
Let's skip that intro. Here you can see that we can move the character and we can type commands, and the game will read back the game's responses to us out loud.
This is Graham's home. It's one of many homes in the Kingdom of Daventry. Graham keeps the place neat and tidy. In the center of the room is a large table. There's a small counter with a hat on it in the corner. A stove warms the room.
Now what we're going to do is we're going to transfer control over to the AI by clicking this button. And what's happening now is that the AI, which in this case is Grok, is now inspecting the image and everything that it knows. And here's what it knows so far. Not a lot. The other part of the context that we can't see here is the prompt. And let me show you that. So here are the instructions on how to play an adventure game.
Look, stove.
The stove is made of cast iron and keeps the room toasty. There's a teapot on top of the stove.
Notice that the AI comes back, it issues a command, and then immediately starts thinking about the next command. We also create a visual overlay of what the AI thinks it sees.
Look, pot.
You don't have it.
And you can see how it just has control and it keeps control. Now we can open up the thinking or the brain of the AI here and see the context that it's working with. And you can see based on the instructions, it has a world map, a list of objects, a list of quests that it thinks it has, as well as some analysis.
Move me to the table.
Now the AI has asked us to move the character to the table. In fact, it's actually the AI engine client that has asked us to do that. The AI has provided a path and it shows us that on those magenta markers. And we're just doing that because right now we're punting on moving the character because the AI likes to plot paths through objects and often really close to objects. So once we manually move the character, then we go ahead and just pass control back to the AI. Now, the only other thing I want to cover in this game is that you can see how closely aligned the vision system is with the objects in the room. And this suggests that the vision system is doing a great job of detecting every object in the room and doing a killer job of identifying bounding boxes. And that's just not the case. Grok's image recognition capabilities are there and they're pretty good. But in this room specifically, we are giving hints about where things are, just to take that out of the equation. Now we're going to jump over to Leisure Suit Larry, which is a cult classic, of course, and you're going to get to see that this is a generalized engine. There's no different rules or different code running for this specific game, and there will be no hints for the vision system, so you'll get to see that and how it works. All right, classic theme there, but let's mute that for now. And here you can see we're outside of Lefty's Bar in Leisure Suit Larry. I'm going to go ahead and open up the developer tools here so we can see the game's thinking. And we'll start by giving control to the AI. And I'm going to let this run so you get a sense for just how long it takes, and I won't edit any of this out.
Look, building. You are outside Lefty's Bar. Isn't it wonderful what can be done with a little neon? There's a sign on that utility pole.
Now we can see the true work of the vision system. You can see it's good at identifying what's in the scene, but not very good at putting bounding boxes around it.
Look, door.
You're not close enough.
Okay, that's a great hint. And you can see that it thinks the door is the sort of the forced perspective to the right of the actual door.
Look, windows.
The windows are too dirty to see through.
And you're getting a sense when it's not doing a deep image analysis that it's a little bit quicker. And also, again, that it sort of loses concentration. It's actually looking around instead of maybe going right for the door.
Look, sign.
Taxi. Stand.
So what we can do to try and understand what's going on is open up the brain and see what the analysis shows. Here we can see that open door is on the list of quests and it's not completed yet, so we'll see how it goes.
Open door.
You're not close enough.
Okay, that's a major hint. We might be onto something here. Let's see if it wants to go to the door.
Move me to the door.
Okay, it's plotted a path to the door. And we're going to go ahead and move it. You can see here that the plot is not great, but if it was right about the image analysis, it would be pretty good. First, we'll move Larry on the path that the game suggested, and then what I'm going to do is just actually put Larry where he's supposed to be. Now we'll pass control back to the AI.
Open door.
Okay.
Well, we don't get a point for that, but we are inside the bar. Now you do see the visual artifacts from the last screen. These will get replaced when the thinking comes back from the next iteration. And what I'm going to do is I'm going to start speeding things up from the editing perspective because we are at 15 minutes. Just opening up the context, you can see it's taken 7 calls to get inside.
Look room.
This is the sleaziest bar you've ever been in, and you've been in quite a few.
The average call is about 20 seconds. We haven't died yet, and there are no restarts. And these are the basic metrics that I'm using right now to evaluate one LLM against another. All right, let's go to fast mode.
Look jukebox.
You're not close enough. Move me to the jukebox.
Okay, this path that we're on here shows why we're actually manually intervening in walking. And that's because while the path gets us where we want to go, there's a little hook there that we would have gotten caught on.
Look jukebox.
Gee, Dad, it's a Wurlitzer.
Take jukebox.
It's of no use.
Use jukebox.
You insert $1 into the jukebox and select a suitably sleazy song.
Look counter.
It doesn't look interesting.
Look stools.
What's a stools?
Look deer head.
What's a deer?
Look picture frame.
What's a frame?
Look counter.
It doesn't look interesting.
Look counter.
It's just as it appears. Move me to the counter.
Okay, I'm going to jump in here because Larry spends a couple of minutes just doing nothing, looking at the...
Look door.
Yep, it's a door.
Open door.
You're not close enough. Move me to the door.
Okay, another great example here of the plotting issue that we have. You can see that the plot would have moved Larry over to the character, and we'd have to try and walk through the character to get to the door. So we're actually going to just navigate Larry around and then pass control back to the AI.
Look door.
Yep, it's a door.
All right, we're about 37 calls in and no points scored yet.
Open door.
Okay.
Look toilet.
You're not close enough. Move me to the toilet.
Okay, let's walk on over to the toilet. You can see here that the bounding box was a little bit off, and that's why the suggestion for that path was off. But we're going to walk where we need to walk and pass control back to the AI.
Look toilet.
It's not a pretty sight.
Look toilet.
It's not a pretty sight.
Use toilet.
You grab an ancient copy of the Wall Street Journal and settle in to sit and think.
Look sink.
Now?
Look mirror.
Now? You feel a great relief. Move me to the door. Carefully finishing your duties, you wipe and toss the newspaper behind the toilet for the next user.
Okay, you saw that I had to manually intervene and stand there, and that's because that animation does not end until you tell the character to stand. And we're getting up to about 20 minutes here, so I'm going to call it here. We've earned our first point. We've satisfied some base needs here with Leisure Suit Larry. If you found this fun, nostalgic, or interesting, and you're interested in the AI here, regardless of what it is, leave me a like, leave me a comment, share this video, and let me know what you think.